Given question, a compound bar is made up by connecting steel member and a copper member rigidly fixed at their ends. Estimate the stress induced in the members due to rise of T degrees in temperature.
Compound bar is made up by steel material with different cross-sectional area and the copper material with uniform cross-sectional area is held between two fixed supports, and we have to find out the stresses developed due to rise in temperature T. So when the rise in temperature, then there is increase in length. So we have to show this increase in length for the steel bar as well as for the copper bar. So I will show here the increase in length, that is in the outward direction of this bar. I will show this increase in length on both the sides. But the condition is given that these bars are held between two fixed supports. So due to these fixed supports, this extension is getting prevented because these fixed supports applies the force equal to P in the opposite direction. So we have to show if the extension is in the outward direction, then we have to show the mechanical applied force P in the opposite direction. This is for the steel bar and this is for the copper bar. Now in the same way we have to show on the other side. So extension is towards the left hand side. So we have to show the applied force towards the right hand side. So this compressive force P is having equal magnitude but opposite in direction. Now to find out stresses, we will prepare one table. So in the first row we have to write expansion due to thermal energy. So for steel and copper we have to use the value for the coefficient of thermal expansion alpha multiplied by change in temperature T multiplied by original length L. Now if we observe the steel bar, then it is having total length L by 2 plus L by 2, that is L, and for copper bar length is mentioned L. So we will write the formula. For steel we will write alpha S multiplied by rise in temperature T multiplied by L. For copper bar we will write alpha C multiplied by rise in temperature multiplied by L. Now we will move to the next. We have to find out the change in length delta L prevented due to this mechanical applied force P. So how to write this? So we have one formula. Young's modulus E is equal to stress sigma divided by strain, and strain is equal to delta L by L. So we have to use here the value for delta L because delta L prevented due to P. So here we will write therefore delta L is equal to sigma L divided by E. This formula E is equal to sigma divided by delta L by L is applicable because of mechanical applied force P. Now how to define the stress developed due to this P? So we know that sigma is equal to P divided by A, that is applied force P divided by cross sectional area. Now if we observe for the steel, for first half portion area is a meter square. So stress developed we will write as a sigma S. Then for the second half portion it is area is getting changed. So here different stress is getting developed. So we will show here as a sigma dash S. And for copper where area is a meter square we will write the stress developed is sigma C. Now with reference to this diagram we have to write the formula. If we observe for the steel on both the sides, that is for first half and second half, magnitude of P is same, and for copper also magnitude of this applied force is same. So how to write this P? So P is equal to, so from this we can write here therefore P is equal to sigma into A. So for this diagram we will write P is equal to sigma S into A. is equal to sigma dash S into 2A is equal to sigma C multiplied by A. If we observe, A is the common term and we can cancel here, therefore sigma S is equal to twice of sigma dash S is equal to sigma C. So this is the relation in between the stresses for the steel material as well as for the copper material. Now we will fill up here the delta L prevented due to mechanical applied force P. So we have formula sigma multiplied by original length multiplied by E. Now how to write? So for steel, if we observe, for first half portion we have to write sigma S and length is equal to L by 2 and E, value of E, that is E for steel is mentioned in this question, so we will write here as a ES. So I will write here sigma S multiplied by length, original length is L by 2. Sigma S multiplied by L by 2 divided by ES plus, because we have to add these two parts. Now for second portion this sigma is different, so we will write sigma dash S. Now for this sigma dash S, length is L by 2. Sigma dash S multiplied by L by 2 divided by ES. So this is the delta L prevented due to P. Now for copper we will write, instead of sigma we will write sigma C. Original length is uniform length L divided by Young's modulus for copper is EC. Steel bar and copper bar are held between two fixed supports. So we can say that the total expansion due to thermal energy is equal to this total change in length prevented due to this mechanical applied force P. So we have to put the values for this formula. So how to find out total expansion due to thermal energy? That is, we have to add the expansion due to thermal energy in steel plus expansion due to thermal energy in copper. So when we add these two values, then T and L are the common term. We will take outside the bracket and we will write alpha S plus alpha C bracket complete TL. Now how to write the total change in length prevented due to mechanical applied force P. So here delta L prevented due to applied force P we have written in for this second row. So we have to add all these terms. So we will write sigma S multiplied by L divided by 2ES plus sigma dash S into L divided by 2ES plus sigma C into L divided by EC. Value of alpha S and alpha C is mentioned in the question. Alpha C is 1.5 alpha and alpha S is equal to alpha. In the same way, value of ES and EC is also mentioned. EC is equal to 0.5 E and ES is equal to E. So we will put the value and rewrite this equation. So this 1.5 alpha plus 1 alpha, that is 1.5 plus 1, 2.5 alpha T. If we observe here this equation, there is L as a common term on both the sides, so we can cancel this term and we will write here alpha 2.5 alpha multiplied by T is equal to, now sigma S divided by 2ES. So instead of ES we will write E, so sigma S divided by 2E plus, now we will write here this term sigma dash S in terms of sigma S. So how we can write here? So twice of sigma dash S is equal to sigma S, therefore sigma dash S is equal to sigma S by 2. So if we write sigma S by 2 here, then this 2 multiplied by 2 is 4, that is sigma S divided by 4E plus sigma C. So here sigma C is equal to sigma S. So we will write sigma S divided by EC is equal to 0.5E. Now if we observe, we have to take common denominator. So here 4E is the larger term. So if we multiply here with 2 by 2, then here it will become 4E. And if we multiply here with 8 by 8, then this denominator will become 4E. So we can write here twice of sigma S plus sigma s plus 8 sigma s divided by 4e. Now this 4e we will transfer to the left hand side, and on right hand side there is 11 sigma s and is equal to 10 alpha Te. Therefore sigma s, that is the stress in steel, we have to find out as 10 by 11 alpha Te. So this is the formula to calculate the stress in steel. What about the sigma dash s? Now sigma dash s is equal to sigma s by 2. So if I write here sigma dash s, then here it will become sigma s by 2, and this 2 we have to transfer to the numerator. So it will become 20 by 11. So here it is 20 by 11 alpha Te. So this is the formula to calculate sigma dash s. Now what about sigma c? So sigma c is equal to sigma s. So same formula is used to calculate stress in copper bar.